Hi again, higher chemistry students, back to Unit 2 Nature's Chemistry with Section E, Soaps, Detergents and Emulsions. We're specifically going to concentrate on Part 1 of this topic, soaps and detergents. Soaps are produced by the breakdown or hydrolysis of fats and oils, which we learned about in the last lesson. However, if you use an alkaline catalyst, rather than form your 1 mole of glycerol and 3 moles of fatty acids, you will form still your 1 mole of glycerol, but this time 3 salts of fatty acids, which we call soaps, as shown in this diagram. On the next slide, we'll look at this in a little bit more detail. So we have the same diagram. We have our fat or oil molecule, and as always, during hydrolysis, we break apart the 3 ester links as shown. So we have one of the ester links circled in red, and we always break the ester link between the C double bond O and the single oxygen. We do this 3 times, hence we need 3 moles of sodium hydroxide, NaOH. In the hydrolysis of the fat or oil, the H of the NaOH in this case joins on to the O to form your glycerol. What's therefore left behind are 3 NaO negative ions. They can then attach themselves to the C double bond O, forming our fatty acid salt, which we give the name soap. So soaps have 2 very distinctive parts. They have a hydrophobic tail and a hydrophilic head. Hydrophobic, hydro meaning water, phobic meaning fear of. They have a fear of water, therefore they do not dissolve in water, but better dissolve in oils and grease. Therefore, we say they are soluble in oils. Your hydrophilic head, again hydro being water, philic being a love for, so the hydrophilic head does dissolve in water, therefore likes the water and does not dissolve in oil or grease. So we can represent the soap as the diagram shown at the top, or we can simplify it with the diagram at the bottom. Because soaps have 2 very distinctive parts, the hydrophobic tail and the hydrophilic head, on contact with water, the head and tail separate. And this is how the cleansing action of soap takes place. The tails directly make a beeline for the grease, dirt, oil, whereas the heads, when separated, bob about in the water. We'll see a better diagram on the next slide. So in separating, when the tails make a beeline for the grease, the heads bob about and the tails themselves can drag up the grease into smaller droplets. Then other tails can surround those little droplets, solvating the droplet and therefore causing little droplets of grease rather than an entire mass in the water. And these little droplets are easily washed away. However, when drawing a diagram, you must draw the tails fully inserted into the droplet of grease or oil, with the little head, the COO negative part of the tail, outside of the head, outside of the oil droplet. Detergents are very similar to soaps. Obviously, there's a clear difference. Soaps tend to be of a solid variety, detergents tend to be liquid. Soaps can often leave behind a scum. Those little flakes that are left behind on your soap dish, you tend not to get this with detergents. And detergents work better in areas that contain hard water. In Scotland, we are very lucky. We have soft water, so we tend not to gather a lot of lime scale. It's different in other parts of the UK. But very, very much like soaps, detergents also have the specific hydrophilic head and hydrophobic tail, and they work on the same principle with their cleansing action. Now please try exercise E part 1 and enjoy.